is I'm just going to make sure it looks like it pulled my method correctly. I had 4 analytes in there. I see 4 analytes right here. I've got Delta 9, THCA, and the deuterated forms. Seems pretty reasonable, and the software already knows which one are the internal standards based on when we check these boxes here in the method. So it makes it a little easier when we go ahead and specify that, so when it brings it here, it knows exactly what I'm trying to do. Alright, so the next thing I want to do is I'm going to go to retention time setup, and I'm going to make sure that it assigned the retention times correctly. Now, Delta 9 we know is not in there, so I'm not too worried about that one. We are seeing some Delta 9 in there. I'm not surprised, just based on your standards. A little bit of stuff's going to decarb into there. That looks fine to me, but really the big one's going to be your THCA, and then the deuterated form of your THCA. Now, I want you guys to note down here. So we talked about quals and quants. I'm sorry, I'm going to stand for just a minute so we kind of talk about this. Alright, so this is really where that comes into play. So if I see a peak here, I know it. So up here in the headers over here, you can see what that transition is. So this is a chromatogram built just off of that transition 357 to 245. This is a transition built off of going to 191. So the software is going to automatically assign the most abundant is your quantifier. Everything else will be a qualifier. So part of what you want to do to make sure, how do you know that's the correct peak? Your qualifier ion and your quantifier ion chromatographically should line up on top of each other. Because they're coming off the column at the same time, it's the mass spec that's making the different fragment ions. So what I look for here, it assigns the retention time for this 245 ion right at 8.14. My qualitative ion over there at 191 has the exact same retention time. That's how I know I got the right analyte. Coming off the column the same way, the mass spec is just fragmenting it differently, and we're measuring those different fragments. So if you had a second peak here, and let's say you had hypothetically a peak over here, but you don't have it over there, how do I know that peak over here isn't your analyte? Because your qual and quant did not have the same retention time. Does that make sense for everybody?
Yeah.
This is going to be important when you're looking at evaluating data. Use your eyes. Make sure quals and quants are lining up, because triples are notorious for having what I would consider ghost peaks, meaning that stuff can get through your quad that weighs the same out of there. Specificity comes in. What's the likelihood that something weighs 357 and creates a fragment at 245? That's not the only thing in the world that can do that, but what's the likelihood that I see that? Plus, I can also add in that 191 fragment mass. When I have that, it's pretty, it's really solidifying the